AI is changing everything, from how businesses make decisions to how machines understand language and images. But here's the truth nobody talks about. AI can't work without data mining. It's the process of digging through raw data to find the patterns that make AI smart. This video course is Introductory Data Mining. The book the material comes from is Data Rookies, Data Mining Basics, available from Data Analytics Curriculum LLC and can be direct downloaded from the website. In addition, there are supplements and lab exercises for download. Let's begin with Chapter 1, Foundations of Data Mining, Section 1 to 5 Tools. In this video, we'll look at the main categories of data mining tools, from simple spreadsheets to advanced programming environments, and how each one fits into the analytics workflow. We'll also talk about why theory matters more than any single piece of software. By the end of this lesson, you should be able to 1. Identify categories of data mining tools. 2. Compare the capabilities of general-purpose, statistical, BI, and programming-based tools. 3. Understand the role of programming in data mining. 4. Explain the strengths of visual tools like Orange. 5. And finally, recognize that while tools change, theory remains the foundation. Why focus on theory? Let's start with a key idea. Why focus on theory at all? The answer is simple: software changes, but theory lasts. Over time, analytics tools come and go. 10 years ago, Excel dominated everything. Then came R, Python, Tableau, and now AI-driven platforms. But the core principles behind data mining, classification, clustering, association, prediction, stay consistent. When you understand why a method works, you can easily transfer that knowledge to new tools. That's why this book and course are software agnostic, designed to build durable, adaptable skills that go beyond specific products. Let's begin with the most familiar category: general-purpose tools. These include programs like Excel and Google Sheets, tools most people already use every day. With add-ons such as Excel Miner, you can perform some basic data mining tasks like regression, clustering, or simple prediction. They're great for cleaning, summarizing, and quick visualizations. But they have clear limitations. They can't handle large datasets or complex modeling, and they're not scalable for enterprise-level analysis. Think of them as a good starting point, but not the final destination. The next group is statistical tools, like SPSS, SAS, and Minitab. These packages blend traditional statistics with limited data mining features. They're commonly used in academia, healthcare, and corporate research. The advantage is depth. They provide strong statistical modeling options and robust output. However, they're often proprietary, expensive, and less flexible than programming tools. If you're in an organization that already licenses these tools, they can be powerful. But for independent learners or educators, the learning curve and cost can be barriers. Then we have business intelligence and visualization tools, including Tableau, Power BI, and others. These tools specialize in dashboards, interactive visuals, and data storytelling. They're perfect for communicating insights to non-technical audiences. However, their focus is on visualization, not modeling. They don't offer full-scale data mining algorithms like clustering, decision trees, or machine learning pipelines. And a small note: Power BI still lacks complete support for macOS, which can affect some users. So, BI tools shine in presentation and exploration, but not in advanced predictive modeling. Now let's move to programming-based tools: R, Python, and SQL. These are the engines that power modern data science. They offer unmatched flexibility and customization. You can clean data, build models, automate pipelines, and even deploy applications. Each has its strengths. R excels in statistical modeling and visualization. Python dominates automation, machine learning, and AI workflows. SQL is essential for working with relational databases and large-scale queries. Your skill level depends on your role. Data scientists often code daily, while analysts may use prepared scripts or notebooks. Either way, understanding some programming expands what you can do and how deeply you can explore your data. Finally, let's look at visual data mining tools, a category designed to make analytics accessible to everyone. These tools are perfect for beginners, teaching, and visual learners. They let you build workflows through drag-and-drop interfaces, with no coding required. A great example is Orange, an open-source visual analytics tool built on Python. You can easily combine widgets for data import, visualization, and modeling, all within a single visual workspace. Orange is widely used in research and education, making it an ideal bridge between theoretical learning and hands-on practice. It's a great way to understand the logic of data mining before diving into full-scale programming. Remember, the book and supplemental resources are available online at Data Analytics Curriculum's website.